Okay, we're good. We started it. So multiplying. We're going to do multiplication first. Here I have 7 over 8 times 1 over 2. By the way, they could this is the beautiful class in which everyone is taking the GD. By the way, let's take a quick little off-course moment. And everyone clap your hands. Congratulate Veronica for passing her math GED. Yeah. Yes, she did. So, congratulations. Everyone at home is hearing this, so they're clapping their hands too. But those of you that still are going to be taking your GEDs, a question on the GED might look like this. Oopsies. It might say, what is the product of 7 over 8 and 1/2? Do we know what product means? Yeah, the answer to a multiplication problem, right? So don't be shocked with today's practice problems and in the quiz if you see something like this and the question is, what is the product of this? Just keep in mind it just means you're multiplying. So whatever. 7 over 8 times 1/2. Do we know what to do here?
Cross multiply.
So, no. Good guess, because that's actually going to come in handy in like literally a couple minutes. So here's the thing. The reason why students love multiplying fractions, is because it's pretty simple. It does not have a rule of it has to have the common denominator. It doesn't. Multiplying fractions is easy. You just have to multiply straight across. What is 7 times 1? What's 8 times 2? Now, there are two things that I always tell you, is if you ever come out with the final answer, is A, check whether it could be simplified, right? Or B, check whether it's an improper fraction and make sure to always convert it into a mixed number if it is an improper fraction, right? So ask yourself, could 7 over 16, could that, A, is this a improper or a proper fraction?
Proper fraction.
So now B, could it be simplified?
No.
No, it cannot. Why? Because we have our famous 7 there. 7 is only divisible by 7. I already know that. Remember our little 3, 5, 7, 11? These are those unique numbers that are only divisible by itself. So the only thing you could do if you try to simplify is simplify by 7, which does come out 1, but 16 divided by 7 does not come out a whole number, which means you can't simplify. All of that is irrelevant. You know that 7/16 is your answer. So, multiplication. Multiply straight across. Check whether your answer could be simplified or converted to a mixed number, and then you're done. Isn't multiplication pretty easy?
Yeah.
Pretty straightforward, right? Cool. That's multiplication. But when you have large numbers, large numbers, let me see if I can find a good example here. So we have 7 over 8. (16 over 1). That's technically a whole number. So 7/8 times 16 over 1, right? You could, if push comes to shove, multiply straight across and come out with your answer, right? But the thing is, a lot of students, A, do not like multiplying big numbers across, 7 times 16, right? And even if they did, they'll have such a massive fraction that when they go to try to simplify it, it's just more work, right? Simplifying is fun, but for some students it's not. So there's this trick that you could use when multiplying fractions that I really do suggest you spot always. If you see that that you're multiplying, obviously, do this, you guys. Check your cross fractions. I don't know how to phrase that. So this is what I mean. Always check the numbers that are across from each other, right? And just check whether those could be simplified. This is what I mean. 7 in your 1. Write it out somewhere. Could 7 over 1 be simplified? No, it's a 7 over 1. It's already simplified. 1 is as simple as you can go, right? So you're done with that one. What about your 16 and your 8? Could that be simplified?
Yes.
To what?
8, 4.
Well, yeah, actually that's correct. Let me move all this. If you wanted to do the whole divide by 2 trick, which everyone loves to do, 16 divided by 2? 8 divided by 2? Okay, now you just got to check whether 8/4 could be divided or simplified anymore. If you want to do the same trick, divide by 2, so be it, fine. Like I said before, with simplifying, you'll eventually get the hang of spotting the number that goes into both of them right away, right? But if you want to do the divide by 2 trick, go for it. 8 divided by 2 is what? 4 divided by 2 is what?
2.
Now, could 4 over 2 be simplified?
Yes.
To what?
1/2.
Man, if you wanted to continue on with the trick of dividing by 2, go for it. What we end up getting is 2 over 1, right? 4 divided by 2 is 2. 2 divided by 2 is 1. That's what 16/8 simplifies down to. Do we get that? Why did we do all that? For a very, very fun and cool reason. Because now you could literally get your new simplified fraction and instead substitute it in for the 8/16. What you could honestly do is take out this 16 and put in that 2. You could take out that 8 and put in instead that 1, not 2. Right? So now the new problem looks like this. 7 over 1 times 2 over 1. Don't you think that's a lot easier now to just multiply straight across? Tell me, what's 7 times 2?
14.
What's 1 times 1? So what, it's 14 over 1? I know it's as simplified as it gets because it's 1, right? But you could take the long route and spot that this is an improper fraction and convert it to a mixed number. But if you notice, what did I just say? Any number over 1, what is it? No.
It's a whole number.
It's that whole number, 14. So 14 over 1 is just 14. But the trick that I wanted you to see was always spot your your cross multiplication or cross fractions. The 16 and 8, that could have been simplified down to 2 over 1. So you actually put those in for the 16 over 8 so that you could multiply straight across. Now, you could have done that with the original problem, the 7 times 16. But like I said, spotting your cross fractions and seeing whether those could be simplified right off the bat makes your life a lot easier because you might deal with some large numbers today. I don't know. And you guys might deal with large numbers on Thursday.
I don't like that. My brain is only used to this.
But as long as you spot whether you could simplify right off the bat, you could make a large fraction problem into something a lot simpler. And that is the same thing, well, kind of the same thing for multiplying mixed numbers. No, that's straight up the same thing as multiplying mixed numbers. The only difference is when you're given mixed numbers, what must you do first? What if you're... What if you're given this? Literally, convert it back into an improper fraction, right? And then just multiply straight across if... No, don't just multiply straight across. First, check whether there's anything to simplify. Actually, let's do this one step by step. Let's convert this one into an improper fraction. What must I do?
3 times 2 plus 1.
3 times 2 plus 1. So 3 times 2 is 6 plus 1, 7. Times, what's 4 times 3? Plus 3?
15.
Ooh, this was a good one. I made this problem up and it actually could work. Good. So this determines how much work you're going to put into your problems. Are you going to take the path of just multiplying straight across, right? Because obviously that's what you can do. And then get a large fraction problem and then simplify, then simplify, then simplify. Or are you going to just take 5 seconds out of your life and check whether your cross fractions could be simplified right off the bat? So 7 over 4, your 7/4 right there, 7/4. Could that be simplified? Again, that's 7, right? It's a very unique number. What about your 15 over 3? Could 15 over 3 be simplified? I got one yeah, I got one no.
They both go into 5. Or no, 3 doesn't.
3 doesn't. I have a yeah, I have a no. Laura? How about I don't know? What do you think? What do you think? Another I don't know.
Where did the 7 come from?
The 7 came because we converted this mixed number into back into an improper fraction. So if you remember, we had to multiply the 3 times the 2, right? What's 3 times 2? 6. And then you add the top number, 6 plus 1, 7. Sorry if I blew past that. So back to this problem right here, 15 over 3. Yes, it could be simplified. They could both be divided evenly by 3. What's 15 divided by 3?
5.
What's 3 divided by 3?
1.
Look at that. It's simplified to 2 whole numbers, right? So again, this is a good example of the trick. What we do now is substitute my new problems. That 15 became this 5. This 3 became that 1. So my new problem looks like this. Now you could just multiply straight across. It's a lot better than multiplying 7 times 15. Now all you got to do is multiply 7 times 5. What's 7 times 5?
35.
What's 1 times 4?
1.
Is that the final answer? What must you do?
Convert into
Yeah. Convert into a mixed number. So before you asked how did we get the 7, and I explained we converted this mixed number into an improper fraction by multiplying the denominator by the whole number, and then whatever that answer was, we added the numerator, right? This is a good refresher for converting an improper fraction to a mixed number. All you got to do is divide that the way it is. 35 divided by 4. How many times does 4 fit into 35?
8.
8, yes. Creating what?
32.
With a remainder of what?
3.
I'm losing space here. So then you get your 3 numbers, remember all this? And rearrange them into a mixed number. That 8 becomes my whole. The remainder will be my numerator. And that same 4 will be my same denominator. 8 and 3/4. But whatever, that was let's recap very quick. Multiplying fractions is pretty straightforward. Multiply straight across. But like I said, take a couple seconds out of your life and spot whether you have anything across from each other that could be simplified right away. That's just so that we wouldn't have to multiply and simplify large numbers. And then obviously same thing that we've been doing. Make sure your improper fraction is not improper. You convert it to a mix. Make sure it's as simplified as it gets. Yada, yada, yada. Right? Right. This was multiplication. What's after multiplication? Who here thinks division is going to be the tough one?
You have to simplify.
Ho, ho, ho. So here's a problem right here. All the examples have 1. It's fine. So here we have a division problem, right? 8 over 1 divided by 1/2. So this is the cool thing about division. There's nothing hard about it. What you want to do is make this division problem into a multiplication problem, and then use the same thing we've just went over. So this is what I mean. This is the rule for division. You ready? This is the rule for division. Get your second fraction. And again, if it's mixed number, convert it to improper, right? But your second fraction, all you want to do is flip it. Flip it. So this whole thing right here ends up becoming 8 over 1, and then my flipped fraction is now 2 over 1, right? Why do we flip it? For the sole purpose of changing this division sign into a multiplication problem. That's right. So division problems, they kind of don't really exist. You just flip the second one and then continue on with your multiplication skills that you've just learned. So look at this one. 8 over 1 times 2 over 1. This one we don't need this anymore. That was the original division problem, right? So 8 over 1 times 2 over 1. What do I do?
You divide or multiply straight.
Straight across. Sure, you could take your 2 seconds out of your life to see whether anything could be simplified. 8 over 1, can't simplify that. 2 over 1, can't simplify that. So yeah, now you can multiply straight across. Keep in mind, no, you cannot simplify 8 over 2. That's across from each other, right? That's like parallel to each other. When I say check whether your things could be simplified, that's your diagonals. But whatever, we checked that it cannot be simplified. So yes, now we just multiply straight across. What's 8 times 2?
16.
What's 1 times 1?
1.
What? Nothing. So 16 over 1. What's that?
16.
Look at that. Your division problem, all it was a multiplication problem hidden. You just always go to the second fraction, flip it, and multiply.
In every division problem?
Every division problem.
Yay.
Every
I like
division problem. Multiplying is the key today, honestly. Today is mostly just, sure, there's going to be division problems. Like I said, second problem, flip it, and multiply it. Yeah. Very quick. One more. For division. But let's do it step by step with a mixed number, because I felt like those were the challenging ones yesterday. So, what do we do?
8 times 40 plus 3.
Convert into...
Yeah, that's a big one. I should have used this example, honestly. But you guys have the skills of multiplying by hand. What's 8 times 4? 8 times 40. What's 8 times 0? 8 times 4. 320 plus 3.
323 over 8.
I don't want to run out of space so soon. Whatever. Over what?
8.
Man, this is a massive one. Okay, let's convert this one. What's 4 times 4?
416.
plus 1
17.
over,
4.
okay, this is a division problem, right? So, what do?
You flip it and then multiply.
Flip your second fraction and make it into a
Product.
multiplication problem. Yeah, we're trying to find the product after we flip it, yes. So we flip it. We get that 17 and we put it at the bottom, and we get that 4 and we put it at the top. And again, we make it into a multiplication problem. All making sense so far? All right. Now what?
We take a couple seconds out of her and then
Out of your existence, yes. You take a couple seconds out of your existence and you do what?
Cross multiply. Or you see if
Just
it
check.
can be reduced.
Just check your crosses and see whether they could be reduced. Perfect. 3, 23, and 17. Probably. How about we do the easier one? 4 and 8. Could that one be simplified, your 4 and your 8?
yeah.
To what?
2 over 1.
2 over 2.
Oh man. 4 over 8. If you divide this one by 2 or whatever, but I'm just going to jump straight into it. You guys should be able to spot these right away. 4 is divisible by 4, right? Creating a 1. What's 8 divided by 4?
2.
So this just literally simplifies down to 1/2, right? So you could just multiply straight across, but yes, take a couple more seconds and check whether this one could be simplified. Do we want to do this one? Of course we do, because we do not want to. If we did multiply straight across, 323 times 1, we already know it's 323, right? But just for fun, let's check this. Let's check this. 323 divided by, or over 17. What do we want to divide by?
17.
It's literally the only number that I see, right? Because 17 is not divisible by anything else. So then ask yourself, what's 323 divided by 17?
19.
Yeah, I was going to do it by hand. Did you use a calculator?
Yeah.
Let's do it by hand. Let's just do it by hand on a clean slate. 323 divided by 17, right? How many times does 17 fit into 32? Once. Because 17 times 2. What's 7 times 2? 14. 2 times 1 is 2 plus 1 equals 34. That went over. So we can't use 2. 17 only fits into 32 one time. And it fits into it, well, 17, right? When you minus that, what's 32 minus 17?
12 equals
Mm-hmm.
5.
2 minus 1. Bring down the next number, 3. How many times does 17 fit into 153? You're the one that used the calculator. You had the answer. 9. Check your answer. You could always check, remember, by multiplying it. What's 17 times 9? Well, ask yourself, what's 7 times 9?
63.
What's 9 times 1? Plus 6? 15. And look at a direct match. That's how I know the 9. It's 9. But the reason why we did that division was because it simplified down to my 19 over 1. Right? Because now I could actually cut that 323 down to 19 and cut that 17 into a 1. Now everything is simplified. Now you can just multiply straight across easily. This is a little messy. 19 times 1, 2 times 1. Let me rewrite it. This is my new problem. What was the other one? 1. That's what that huge, intimidating problem now looks like. All because we simplified by looking at our diagonals. What's 19 times 1? What's 2 times 1? Could that be simplified, or does that need to be converted to a mixed number? Yes, it does. It's an improper fraction. It needs to be simplified or converted to a mixed number. How many times does 2 fit into 19? Creating a remainder of 1. Get those 3 numbers. 9, 1, half. Woo! That was a big one, right? Luckily for you guys don't have to deal with too much like those in today's worksheet. But nonetheless, that showed everything. From our original problem of this, we used all our steps. We converted it into an improper fraction. We didn't want to multiply 323 straight across by 4, although you could, right? But instead, we preferred to check our diagonals and simplify it right off the bat. Our 4 over 8 went in, simplified down to 1/2. Our 323 and 17 simplified down to 19 over 1. And then you multiplied straight across, creating... I'll shut the door. You don't have to worry about that. I know. And we got 9 over 1/2. Did that make sense? Ooh. Alrighty. So now we test ourselves. But before that, any questions? Alrighty, let's do this.